When I energize the immersion heater, I'm activating 3 circuits. One is a circulating lube oil pump, which is circulating oil through the engine. It is a positive displacement rotary gear pump with an electric motor. The second circuit I'm energizing is a circulating jacket water pump, which is a centrifugal pump. And the third circuit is the immersion heater element, which is heating the water as it travels through the circuit. Once I have that immersion heater in operation, it's always a good idea to turn on my control power. I'll see circulating oil temp low, which is normal because the oil temp is low, and I also say circulating oil pressure low. Now once that circulating oil pump's in operation, I would expect this alarm to extinguish within a minute. And there it goes. So what that is showing me is that I do have oil pressure circulating throughout the engine right now. Not in the upper gallery because the prelude valve hasn't been opened yet. But if this light doesn't extinguish, if this alarm doesn't reset, then my circulating oil pump on the lower level could be airbound. There's a little petcock on top of the pump that I could open that up, crack that open, and vent the air off. I do want to use a can though and catch any oil, because if it squirts out, it's going to make a mess. So when you push that immersion heater button on the control panel, you're not just pushing a button and starting something, you're actually energizing 3 individual circuits. The whole purpose of the immersion heater system is to warm up the engine's jacket water and lube oil in preparation for startup. So when you do energize that immersion heater system by pushing the button, what you're doing is you're energizing a heating element that's going to heat the jacket water. It's like a mini hot water heater. It's about that long, about that big around. It's got jacket water going through it, and inside there's a heating element. Heats up the water. So you're energizing the immersion heater element to heat that water up. You're also placing in operation or energizing 2 different pumps. One of them is the circulating oil pump. The circulating oil pump is a positive displacement rotary gear pump. And that's going to circulate lube oil from the sump back to the sump through the lube oil's heat exchanger. You're also energizing a circulating jacket water pump, which is a non-positive displacement centrifugal pump. Has an impeller. So a non-positive displacement pump is pumping the water because water is a non-viscous liquid, and since oil is a viscous liquid, we want to use a positive displacement rotary gear pump. There's a lot of good videos in the Junior Engineer folder. So if you go to the Junior Engineer folder, click on General Subjects. The folder says General Subjects, that's 1.0. Scroll down till you get to the folder that's labeled 1.16 or 1.16, and it's titled Pumps, Fans, and Blowers. There are 6 really good videos on the differences between centrifugal pumps and positive displacement rotary gear pumps. I suggest you check them out. So part of that immersion heater system, push the button, energizing 3 circuits, the heating element, circulating jacket water pump, circulating lube oil pump. It goes through a circuit. So let's put it on the board so you can see what this circuit looks like, the flow path of the jacket water, because it goes through several different components. So let's take a look at that. Honestly, I don't know what takes you guys so long to do system drawings. You should hire that guy. Here's what it looks like. So we've got the system on here, on the board. I've used the blue. I've had him use the blue to indicate the jacket water flow path. So starting with the pump. This is the circulating jacket water pump. That non-positive displacement centrifugal pump. So that pump, that's a symbol for a centrifugal pump, by the way, is pumping water. We've got two pressure gauges so we can see what the inlet pressure is and the outlet pressure. There's supposed to be a differential pressure of 7 to 10 psi. We can adjust that differential pressure by opening or closing this throttle valve. So following the flow path of the jacket water, it's going to go past the throttle valve into that immersion heater where it's going to pick up some heat because we've got the heating element energized. And as it goes through the immersion heater, you'll notice there's two more temperature switches here. We've got a total of 3, but the first one here is set for 170 degrees, and these are all in Fahrenheit. That is the over temperature switch. So if there's some kind of a malfunction with the regulating temperature switch and it exceeds 170 degrees, the entire system will shut down because this temperature switch said so. The other temperature switch is our regulating temperature switch. So it's set to operate between 120 to 140 degrees Fahrenheit. Now it's not the switch that's operating, it's sensing the temperature of the water, and if the water temperature is below 120 degrees, the heating element that's immersed in the water inside the immersion heater will energize and transfer heat to the jacket water. If that jacket water temperature being sensed at this temperature switch reaches or exceeds 140 degrees, the heating element will be de-energized. And as the temperature cools again, it gets to 120 or below, it re-energizes it, so it maintains the circulating jacket water temperature between that degrees of 120 and 140 as sensed by this temperature switch. Now, if this temperature switch fails and doesn't de-energize the immersion heater, then when that temperature reaches 170 degrees, game over. It shuts it down. So we're going to have some human intervention here and do something about it. So we'll go over here and take a look at the immersion heater pump. We're on the lower level, starboard side. There's our circulating jacket water pump, which is part of the immersion heater system. That's circulating jacket water through the circuit, through the lube oil heater / heat exchanger, and it's also circulating jacket water through this immersion heater, which is covered by a lagging pad right there. That gray pad. Inside that, or underneath that gray pad, it's just a heater. Just a water heater. And the two temperature switches are right there in the circuit. So there's the first one right about mid-screen, and there's the second one. So on the two pressure gauges, we're looking at maintaining a differential pressure of approximately 7 psi coming out of the heat exchanger and 15 going in. I can adjust that with the throttle valve if I need to on the discharge side of the pump, but I've already got that adjusted to maintain my desired differential pressure. Next component downstream you'll see is a check valve, a swing check valve. So it allows flow in one direction only. And now the jacket water, that heated jacket water, is going through the heat exchanger for the lube oil system. So at the same time, and I didn't illustrate that positive displacement rotary gear pump that's taking a suction from the lube oil sump and pumping it through the heat exchanger. This is your positive displacement rotary gear circulating oil pump. One for each engine. So this is a tube and shell heat exchanger, which means there's a bundle of tubes enclosed in a shell. So on the outside of the tubes, we've got warm jacket water circulating from one end to the other, and on inside of the tubes, we've got lube oil circulating. So if there's a temperature differential between the temperature of the jacket water and the temperature of the lube oil, well, heat transfer goes from hot to cold. So assuming when you set this system up and you energize that system, the lube oil temp's cool, the jacket water temp's cool, but as that temperature increases, you're going to start getting heat transfer. So we're warming up the contents of the sump as far as the oil gallons are concerned. So every time that lube oil goes through the heat exchanger, it picks up a little bit of heat, dumps it back into the sump, picks it back up again. So every time it cycles through there, the temperature is slowly increasing. So what we're doing is we're heating water because it's easier to heat water and it's easier and faster to pump the water because it's a non-viscous liquid. So through the heat exchanger, the jacket water goes. Then it comes out of the jacket water, out of the lube oil heat exchanger, I should say. So the jacket water comes through the lube oil heat exchanger on the outside of the tubes, comes back out, goes through the engine's water circuit, and starts warming up the engine block as well. So it's coming out of the engine block, going back over here past this temperature switch. Now we're into the normal jacket water system that the attached jacket water pump would normally be pushing this water through. That's why there's another temperature switch up here. So it is set for 190 degrees, which means during normal operation, if the engine's jacket water temperature reaches or exceeds 190 degrees, you will get a high jacket water alarm. That's one of the alarms on the main engine's alarm panel. There's one of them, right? There's more than one. So that's a temperature switch, and it's just sensing the temperature of the jacket water. Downstream of that, we've got an orifice that kind of restricts the flow, so it's smaller than the inside diameter of the jacket water piping. And then that jacket water comes down to this guy right here, which is a regulator. So it's also a temperature sensing device. And you see I have the temperature written up here, 165 degrees or 180 degrees. So here's the assumption. If the jacket water temperature is 165 or less, we don't need to get rid of any heat. So the jacket water will be redirected in this direction. As the temperature of the jacket water, now this would normally happen when the engine's running because this is going to maintain this temperature at 140 max, so between 120 and 140. So we should never really see the regulator start to open to the cooler or the heat exchanger. But once the engine's in operation, our normal jacket water temp is going to be a little bit higher than 180, right? So at 180 degrees, this regulator is 100% open, sending all the jacket water through the jacket water heat exchanger. So we can get rid of some of that heat. So the same thing, it's a tube and shell heat exchanger. So going through the tubes is the raw water. Seawater, river water, whatever raw water source you happen to have. So through the tubes is the raw water. Through the outside of the tubes is the jacket water. So seawater's going through the tubes, coming in, going out, going overboard. Raw water's going over the outside, and if you have a temperature differential, you're exchanging heat. So heat always goes from hot to cold. Comes out of the jacket water heat exchanger, goes back through here, and that's basically it in a nutshell. I didn't put a whole lot of illustration part of the lube oil part of it because it's just that simple pump circulating oil from the sump through the heat exchanger back to the sump. So once again, oh, and then we got the expansion tank. Can't forget the old expansion tank at the top. So that's where this is tied in. So flow path, you can see there's a check valve over here. I don't think I mentioned that yet. This check valve over here, because we're throttling this differential pressure, some of that liquid is constantly going just into the engine block. So it doesn't go through the heat exchanger. We're sending a portion of it through the heat exchanger, warming up the water, transferring that heat from the water to the lube oil, circulating it through the sump, and circulating warmer jacket water through the engine block. So by morning, if you do the immersion heater correctly, you do it the day before, 24 hours before you start the engines up. By morning, when you show up to start up the engines, you can expect that your jacket water temp is probably around 120 to 140 degrees, somewhere in that range. And as a result, your lube oil temp's going to be that warm as well. And the engine block's going to be that warm. It's always easier to start a combustion engine when everything's nice and warm and toasty. Okay, so that's it with the immersion heater system. It's not just pushing a button. There's a lot of stuff going on. So, that's all I got to say about that. You can bet there'll be a quiz though. Oh yeah.